There is a significant gap between the raw back-end code used to retrieve information and the visual dashboards that drive business decisions. If you work on the back end, you already know how to write the queries required to process millions of rows. But business stakeholders rarely want to see a terminal script. They require clean, executive-ready presentations. For developers used to the strict logic of a relational database, moving into front-end tools like Excel can feel unconstrained and less rigorous. This Redenta Academy documentation highlights the golden rule of analytics. Every action you take in a spreadsheet has an exact programmatic equivalent in SQL. You are not learning a new logic system from scratch. You are simply learning a new interface. This split-screen framework allows us to map strict code syntax directly into front-end spreadsheet actions. Translating back-end syntax into these features allows you to manipulate and summarize massive datasets at incredible speed. Your existing mastery of SQL provides a direct technical foundation for high-speed front-end analytics. Apply this logic to a common operational bottleneck, the Friday afternoon fire drill. At 4:30 p.m., a VP drops a file of 50,000 messy transactions on your desk, demanding a revenue summary by region for a board meeting. Your first instinct is to write a query. You would write a select statement, wrap the revenue in a sum aggregate function, and group the results by region. You clearly cannot add 5,000 rows manually with a calculator. Instead, you use the exact spreadsheet equivalent of that group by, a pivot table. To define the grouping, drag the region column into the rows section. To execute the aggregate math, pull the revenue data into the values box. The grid instantly calculates the totals. This drag-and-drop action executed the exact same relational algebra as your SQL query, without typing a single mathematical formula. Pivot tables are the ultimate tool for instantly collapsing raw rows into executive summaries, meeting the Friday deadline in minutes. A warehouse fulfillment crisis provides the next challenge. The floor has 10,000 pending orders exported with only a product ID, but the human packers require a readable product name. The names exist, but they are housed on a completely separate master inventory sheet. On a backend server, you would resolve this with a standard relational join, using the product ID as the primary key. On the front end, XLOOKUP is the exact formula equivalent of that left join. The formula requires a lookup value, an array to search, and an array to return. The function scans the external sheet, finds the matching key, and pulls the corresponding text string back. Dragging this formula down instantly populates all 10,000 rows with the correct names. XLOOKUP eliminates manual data entry by programmatically linking disparate tables at mass scale. Human cognition processes visual cues like color much faster than raw data. Consider a dataset of server CPU usages ranging from a safe 1% to a critical 100%. Because SQL terminals cannot paint colors, engineers use text-based case statements to flag danger. Conditional formatting is the front-end equivalent of a visual case statement. By applying a color scale rule to the column, crashing servers turn dark red instantly. Engineering teams can now spot system failures in milliseconds based on color patterns alone. When dealing with legacy systems, imported data is frequently messy or poorly formatted. Back-end string functions like trim and upper have identical built-in spreadsheet counterparts used for data cleaning. The text-to-columns tool maps directly to SQL's substring function, allowing you to split merge strings into distinct columns. Mastering these formatting and cleaning tools eliminates the need for complex pre-processing scripts, allowing you to sanitize data directly in the presentation layer. All of these tools lead to the same objective: delivering an executive-ready presentation to non-technical stakeholders. This requires visualization, and as the syllabus notes, SQL cannot draw graphs. To do this correctly, a chart must never be built from raw, unsummarized rows. You always build your group by, the pivot table, first to aggregate the numbers. After summarizing the data, you insert a pivot chart. The graphic builds on top of those aggregated totals. Because the chart and table are linked, any filter applied to the table causes the chart to instantly recalculate and animate for your stakeholders. This workflow, aggregating first, then visualizing, is the same architecture used in advanced business intelligence tools like Tableau and Power BI. Effective data analytics at this level is the application of relational logic through these visual interfaces. By treating these interfaces as graphical wrappers for relational logic, the back-end developer can translate raw complexity into clear, persuasive data stories.